It's not Daniel Winston Tang. That's what it says in the schedule on the website for rechecked. Turns out staff is over controls. And I'm going to be kicking us off with Intro to Backend. So the backend can be a pretty abstract concept. It can be sort of difficult for beginners to grasp at first, mainly because it is so broad and encompasses a lot of things. It's kind of hard to give a concrete definition of what the backend is, so instead I'm going to compare it to the front end, and hopefully we can get a better understanding for it through that. So the front end is basically what we've been doing over the course of, or working on over the course of the past 2 days. At a very high level, it is basically all of the visible stuff on a web app. So all of the buttons, text boxes, drop-down menus, sliders, basically anything that a user can see and interact with. The front end also contains event listeners, and if you remember from yesterday, event listeners are basically just things that fire off functions whenever a certain event goes off, like a mouse click or a key press. You've also probably heard of the terms UI and UX. Those are also terms that refer to the front end. UI stands for user interface, and it has to do with what the layout of the front end looks like, and UX stands for user experience, and it has to do with how a user is actually meant to interact with the front end. And as you've been working on the front end for the past couple of days, and you've probably seen that it is mostly made from HTML, CSS, and JavaScript. On the other hand, the backend is sort of all of the invisible stuff of your web app, basically everything that happens in the background. It includes stuff like processes that compute statistics for your web application, contains methods to actually log in a user to an account on your website, stuff like that. It contains a server, which basically controls access to data for users, and it contains a database, which actually contains the data of the application. And there are many, many frameworks that run in many, many different languages that you can use to write the backend. So JavaScript, Python, Java, Ruby. In this class, we'll be using Node.js, which uses JavaScript, but more on that this afternoon. The point of this lecture is not to build a backend. We're not going to be setting up a server. We're going to be doing that with Monday in the afternoon. The point of this lecture is to basically try to get an understanding of how the front end and the back end communicate with each other. And this is really important because in 6148, you guys are basically going to be building a web app from, I don't want to say scratch, I guess sort of scratch. You'll build both the front end and the back end. And if you don't have any way for them to talk to each other, you'll just have 2 parts and they won't do anything, and your web app will also do nothing. So to explain how the front end and the back end communicate with each other, we're instead going to look at how a client and a server talk to each other. So a client is basically a computer that wants to gain access to some data. And a server is another computer somewhere else that, again, controls access to this data. Don't get confused by the terms ClientServer. At the end of the day, they're both just computers that sort of pass information back and forth between one another. So on the left here is a user. And we are all users of the internet. And when we browse the internet, our laptops are clients for many servers. And the right picture here is meant to be a representation of a server. Now, servers can have multiple clients. For example, like Facebook servers, surely more than one person at a time is using Facebook, so that kind of makes sense. And as users of the internet, we have this tool called a browser, something like Google Chrome, or Mozilla Firefox. Safari is also respectable. We don't talk about this one, so let's run away and go back to Chrome. Basically, we're really lucky to have browsers because they sort of handle all the communication between the client and the server for us. I mean, again, clients and servers are just computers, right? And there's this giant thing called the internet that's standing in the way of them. And somehow, our browser dives into the internet, gets the data we want, and fetches it back for us. Now, casual users of the internet don't really need to understand how this works, but as students of 6148, we're going to have to go into a little more depth in order to connect our front end and our back end. So the way the client and the server talk to each other is through a process called HTTP, stands for Hypertext Transfer Protocol. And I'm sure all of you have seen these four letters somewhere before. In fact, if you're on the internet right now and you look at the top of your browser in the URL bar, these four letters are probably at the beginning of your URL. All you have to understand about HTTP for this class is that it provides, or it is a protocol that provides functions that we call HTTP methods that allow a client and a server to communicate. And the way this works is through a request and a response system. So a client will send a request through one of the HTTP methods to a server. The server will then process the request, compute whatever it needs to in the backend, and then send back a response to the client. There are multiple types of HTTP methods that are used for different things. The most common two are get and post. A get request is used whenever a client wants to retrieve data. For example, if I'm on Facebook.com and I click on my profile page, my browser will send a get request to Facebook servers asking for all of the data inside my profile. A post request is used when you want to sort of send new data to the server. So for example, again, on Facebook.com, if you want to make a new post to your wall, when you click the post button, it'll send a post request to the server with information containing, like, say, the text of your post, maybe timestamps and other information. And then the server will update the database based on when you send it, and then send you a response being like, okay, cool, we got it. So other two ones, or HTTP methods that are also used are put and delete. Put edits data, delete deletes data. You probably don't have to worry too much about those. The main two that you have to worry about are get and post. And I provided a link here at the bottom in case you were curious as to what all the HTTP methods were. Cool. So I've been saying that a client makes a bunch of requests to a server, but what exactly goes into an HTTP request? I kind of think of it like sending mail through an envelope. You need to have like a certain set of things for it to work, right? So you need to first specify the method type, right? So again, that's like get, post, delete, put, whatever. You need an origin. You need a destination, which is basically where you're sending the request. And you need to also provide relevant parameters. So for example, if I'm sending a post request to log into my account on Facebook, I will also need to supply things like my account name and password. And there's some more stuff, but you don't really have to worry about that. So in return, you get a response. So what's in a response? Well, the first thing is a status code. A status code is basically a 3-digit number that tells you basically how your request went. There are 5 types of status codes. They either start with a 1, 2, 3, 4, or 5. Some examples are 200. If you get a response and the status code is 200, that means your request was successful. Another one is 404. That means not found. I'm sure you've all encountered this before. And 500 means that there was a server error and your request cannot be handled. Also, your response will also contain whatever you requested. This is different depending on the type of request that you make. So I'm going to tell you about a get and a post request, or a response. So when you make a get request, your response will actually contain all of the data that you requested, right? So in the response, you'll receive some sort of JSON object, and inside that JSON object will be everything you requested. So if you request like your profile on Facebook, that object will contain things like your name, your username, your statuses, so on and so forth. For a post request, however, you're not really requesting any data, right? You're just sending data for the backend to update itself. So the response that you get will basically just be an indication of whether or not the request was successful. So you'll basically just get a status code. And you'll get some more stuff, but again, you don't need to worry about that. Okay, cool. So after learning about HTTP, hopefully the entire internet between the client and the server is not so scary. If we look under it, it is sort of just a series of requests and responses from the client to the server, and then the server to the client. Any questions so far? let's go through an example. In my first example, my friend over here wants to access the new hot and upcoming social media platform, Catbook. So he types in catbook.com into his browser's URL or bar and clicks enter. Can any of you tell me what kinds of requests my browser would make to Catbook servers? You can say it out loud. Get? Yeah, it would make a GET request, right? Because you essentially want to get all of the files that you need to load or render catbook.com's website. So you send a GET request to catbook.com or to Catbook servers, and in response you get an HTML page. After you get the HTML page, your browser will then look through your HTML page, and then it will see what else it needs to get, right? We've learned that you need more than just an HTML page to render a page on a website, right? You need all the CSS, the JavaScript, and all the assets. So it will send more GET requests to the server, and then when it gets those back, it'll be happy. And then your browser can render the website. Cool. So example 2. Now that you're logged in on Catbook, your user wants to make a new story. So he types into the new story box, the status, new story here, and clicks submit. So what kind of HTTP request do you think this will make to Catbook servers?
Post.
Post, yeah. Because you're sending new data to the server, right? So that the server can update its database with your new post. So you're going to, so when you click submit, it'll send inside of its post request basically all the text that you've entered into this text box, along with some other information, again, like timestamps, your username, your user ID. The server will update its database with this information. It will send a response to you being like, okay, cool story. And when you refresh the page, your post should show up. Cool. So why does this matter, right? Like, we basically learned how a client and a server communicate, right? They communicate through HTTP requests and responses. So a client sends a request to a server processes that request, and then returns back to the client with a response. But how does this relate to the front end and the back end of your web application? Well, if you think about it from the perspective of a user, right? If you're a user browsing the internet, your laptop is a client, right? So let's say you've built a web application and a user is using their laptop to view your web application. What they're going to be interacting with on their laptop, which again is the client, is all of your front end code, right? So they're going to be clicking buttons on your front end, they're going to be clicking links on your front end, and all of that is going to send requests to your server so that you can do stuff with it in your backend. And I've said that the browser takes care of a lot of things for you. Like it makes HTTP requests for you and it deals with responses for you. However, HTML is not like some magical thing, right? If you make an HTML button right now and nothing else, when you click on it, the button won't do anything. So as a web developer, when you create a front end and a back end, you actually have to supply code to all of the buttons and the links in your front end to actually tell it that to actually tell the browser that, hey, when a user clicks on this button, I want you to send a post request to my servers. And you need to set it up such that it sends all of the information that you want. So let's say a requirement of your web application is that you have to have a user account system, right? So when a user registers for an account on your website, they'll likely fill out a really long form with a submit button at the end. You're going to have to attach code to the submit button that says, hey, send a post request to my server with all of the information and all of the text boxes in this registration form to my server so that my server can update it. Or so that my server can add you as a valid user. Okay, any questions? Yeah?
Can you like attach information to a GET request? Like you want to send information?
Yeah, you can also, yeah, so sometimes when you're making GET requests, right, you want to make GET requests to obtain a specific piece of information. So you might send things like, we'll actually go into this later in actually the next workshop. But we're going to be making GET requests to retrieve comments for a specific story. And the way that you get all the comments for a specific story is that along with the GET request, you'll actually pass in the ID of the story. Yeah. Okay. Cool. So we've talked a lot about what your browser can do, and your browser can make HTTP requests. That's cool. But so can you. You can make HTTP requests in your code. So a lot of languages and frameworks basically give you methods to make HTTP requests. And these requests can be done in both the front end and the back end depending on your needs. All you need to supply your methods are these four things, usually. First, you need an endpoint. This is basically a URL. We'll go more into depth in the next slide. You need to supply data. So again, like when you make a post request, you need to supply things like your account name and password. Sometimes, to make requests, you need to supply credentials so that the service that you're using knows you are authorized to make the request that you're making. And often, you will need to supply a callback function. This is basically a function that will run after your API request is complete, and the service will probably pass in the API response to your callback function. Again, we'll get practice with this in the next workshop. Cool, so let's talk more about endpoints. Again, endpoints are basically just URLs that you make HTTP requests to. I like to sort of think of them as being identified by everything that comes after the, what's it called? Domain name. So like the .com, .edu, .org, for example. Basically everything in red on this side. They basically allow the server to know exactly what it is that you're requesting. Right? So for example, if I make an HTTP GET request to catbook.com, as we discussed in example 1, this is the endpoint that you would send a request to if you wanted to get the HTML of catbook.com. For the second example, catbook.com/u/user1, this is the endpoint that you would make a GET request to if you wanted to retrieve the information from user 1's profile. catbook.com/login is probably an endpoint that you would make a post request to when you want to log in on the website. And similarly, catbook.com/story could be an endpoint that you make a post request to when you want to make a new story. Okay, cool. So note that these endpoint names are not like universal or anything. Different services will have different endpoints for you to use. And that is all set up by you guys, the web developers in your backend. Also, just because you know an endpoint exists does not mean you can go around randomly making HTTP requests to your endpoints. A lot of endpoints are reserved for internal use, and so they'll basically be blocked off to the public. However, as users, we are lucky because a lot of services actually provide what we call APIs, which are application programming interfaces. This is basically just a fancy name for a set of endpoints, again, URLs, that are exposed or provided by a service that you can make HTTP requests to. Now, a lot of services provide APIs, and often the collection of endpoints that they provide for you to use will allow you to perform tasks that are relevant to the service. So for example, when I did 6148, my team used the Venmo API, which is sadly gone now because they didn't want to keep updating it. But we used the Venmo API in order to make requests and payments for money on behalf of other people. Something that the GitHub API can do is you can use it to add users as collaborators to a repository. Something that the Twitter API can do is make tweets on your behalf. And there's just so many more services that provide lots of APIs. And it is really likely that when you're creating your website throughout the course of this month, that you will have to end up using at least one API. And if there's a service that you're interested in using and you're not sure if an API for it exists, just Google it. Cool. So the endpoints for an API are often more structured. A lot of them actually contain the letters API in their name. But you can see that in the first two of them, they have, again, some sort of like order to them. They both begin with /API/user, and that sort of gives you an idea of what the endpoint might relate to. And really just through experience of working through more and more APIs, you'll get more and more used to dealing with these. Okay, cool. So that's basically the end of my lecture. To recap, we learned that the backend is basically just sort of, I guess, loosely defined as all of the invisible stuff in your web application, the stuff that users can't see, stuff that allows you to compute statistics or log in a user. Clients and servers are basically just computers that talk to each other, and they roughly relate to the front end and the back end of your code. And they communicate using HTTP methods. And finally, we can make HTTP requests in code, and in fact, a lot of services provide things called APIs, which are just a collection of endpoints for us to make HTTP requests to. Okay. Any questions? Cool. Let's just sit for like 2 minutes while I'll set up the first workshop.